Congratulations and welcome to the Polaris RZR XP 1000 off-road vehicle, the most powerful and exciting side-by-side off-road vehicle on the planet. The Polaris Variable Transmission or PVT system has three components: an infinitely variable position drive clutch, infinitely variable position driven clutch, and a flexible drive belt, which change gear ratio to match vehicle engine output and changing load conditions. When operating a new vehicle or a vehicle with new PVT components or belt, proper drive and driven clutch and drive belt break-in is important. This is accomplished by driving at lower speeds during the first 10 hours of operation. Aggressive acceleration and high-speed operation during break-in can wear system components prematurely and should be avoided as a result. The PVT system transmits engine power to the drivetrain through the engine crankshaft-mounted drive clutch and transmission input shaft-mounted driven clutch. The flexible belt moves up and down between drive and driven clutch sheave faces, providing infinitely variable gear ratios and optimizing vehicle performance in a variety of operating conditions. Drive and driven clutch internal components control initial vehicle movement or engagement, clutch upshift, and clutch backshift. The drive clutch senses engine RPM and operates using internal drive clutch assembly shift weights and springs, which control shifting. When engine RPM increases, centrifugal force causes the shift weights to push against the rollers and the movable sheave, which is held open by spring preload. When centrifugal force becomes greater than spring preload, the spinning outer sheave moves inward, squeezing the drive belt, causing it to rotate, which then rotates the torque-sensing driven clutch, moving the vehicle. At low RPM and slow vehicle speeds, the drive belt sits low in the drive clutch sheaves, maximizing torque. As RPM increases, centrifugal force causes the sheaves to move closer together, which forces the belt to move upward in the sheaves. When the belt is high in the sheaves, torque is low and speed is maximized. The driven clutch senses torque and fluctuates in response to drive belt and transmission input shaft forces. If input shaft torque resistance is greater than drive belt load, the belt remains at the sheave's outer diameter. As engine RPM and horsepower increase, drive belt load also increases, moving the belt up toward the outer diameter of the drive clutch sheaves and downward into the driven clutch sheaves. This action, which increases driven clutch speed, is called upshifting. At constant throttle, if the vehicle is subjected to a heavier load, like when starting to go uphill, the drive belt moves back up the driven clutch sheaves and down into the drive clutch sheaves. This action, which decreases driven clutch speed, is called backshifting. In variable load and constant throttle situations, such as going up or downhill without changing throttle position, the drive and driven clutches shift continuously to maintain optimum engine RPM. The drive belt is the third major PVT system component. Today's advanced technology belt designs make them a reliable and excellent way to transfer power. The clutches maintain belt tension, prevent slippage, and sense load requirement variations to maintain optimum engine torque output and wheel load requirements. Today's advanced belt designs and manufacturing processes result in much higher quality and therefore longer-lasting belts than in the past. Under normal operating conditions and when properly maintained, today's belts are capable of providing months and even years of trouble-free operation when operated properly and within manufacturers' recommended operating parameters. As reliable as today's belts are, they cannot withstand prolonged severe misuse or abuse, and can be damaged and fail prematurely for a variety of reasons, such as exposure to severe heat, moisture, abrasion, and continued high torque load conditions, which over time can fatigue and fail even the hardiest of belts. Periodically inspect the belt for loose or broken cords, missing cogs, cracks, tears, delamination, glazing, and hourglassing, minor to extreme circular wear in at least one spot on both sides of belt, which occurs when the belt clutch engages the belt, but the drivetrain and wheels don't move. like when the vehicle is stuck in mud or snow. Belts with thin spots, burn marks, etc. should be replaced to eliminate noise, vibration, or erratic PVT operation. Whenever changing the PVT belt, be sure to observe and follow these important safety precautions. Locate the vehicle on a reasonably level surface. Place the gear selector in park and block the wheels to ensure the vehicle cannot move. Turn the vehicle ignition switch off and remove the key to avoid injury from component moving parts. System components may be hot after driving. Allow them to cool or use gloves when handling. If a belt disintegrates during operation, be sure to completely clean out all debris from behind both the drive and driven clutches and the inside of the PVT inlet and outlet air ducts. Failure to remove all belt debris jeopardizes engine and transmission seals and clutch components and can cause heat buildup, which may damage a new replacement belt. To replace the belt, remove the PVT cover fasteners and cover to access the PVT assembly and drive belt. Note: it is not necessary to remove the left rear wheel or shock to replace the belt. Insert the shock and clutch tool, located in the vehicle toolkit, into the driven clutch opening and rotate it toward the clutch as shown to open the driven clutch sheaves. Then walk the belt out of the driven clutch and remove it from the drive clutch. Orient the belt so you can read the text. Then loop the belt over the drive clutch and then over the driven clutch. Rotate the driven clutch to carefully walk the belt onto the clutch. Remove the shock and clutch tool and rotate the driven clutch 5 to 7 times to properly seat the belt in the driven clutch. Reinstall the outer PVT cover and fasteners. Then, tighten the fasteners enough to seat the inner and outer covers firmly together. Do not over-tighten the fasteners, as doing so may strip the cover threads. When towing or performing low-speed pulls, place the all-wheel drive switch in the all-wheel drive position so the vehicle's own weight provides weight-distributed all-wheel traction assist. Place the transmission actuator or gear selector in low. Once both are set, gradually apply the throttle to provide smooth drivetrain engagement. This will cause the belt to move up further in the drive clutch sheaves, providing more belt to clutch sheave contact area. It also produces less overall drivetrain system heat, extending both belt and drivetrain component life. Low gear should be used when riding through rough terrain such as swamps, mountains, or rocks, when operating at consistently slow speeds, when loading the vehicle onto a trailer, when starting up a hill from a stopped position, when climbing over large objects from a stopped position is unavoidable. Use extreme caution and operate the vehicle slowly, and when stuck in mud, snow, or similar circumstance. Low gear operation during the aforementioned conditions helps prevent belt hourglassing, slippage, and overheating. It also helps prevent premature belt failure and premature drive and driven clutch sheave wear. To remove water from the PVT assembly and housing, place the transmission gear selector in park and turn the ignition switch off. Then, remove the clutch cover drain plug or cover to drain water from the clutches, belt, and housing. Once the water is completely drained, replace the plug or reinstall the cover. Confirm the gear selector is in park, apply the brakes and start the engine. Apply varying amounts of throttle for 10 to 15 seconds to expel any remaining moisture and to air dry the belt and clutches prior to using low, high, or reverse gears. Do not hold the throttle wide open for more than 10 seconds. Next, allow engine RPM to settle to idle speed. Then, apply the brakes and shift the transmission to low gear and test for belt slippage. If the belt slips, repeat the drying procedure and retest until no belt slip occurs. If belt slip persists after thorough drying, take the vehicle to an authorized Polaris dealer. Congratulations once again for choosing the Polaris RZR XP 1000, the most powerful and exciting side-by-side off-road vehicle on the planet. On behalf of the entire Polaris team, enjoy the ride.